Now that we have discussed the different types of quadrilaterals, starting with parallelogram, trapezium, rectangle, square, kite, we have many other properties which we connect. Now comes the relation between the different types of quadrilaterals which we're going to see in this session. Initially, I would like to find a relation between a square and a rectangle. How would we understand the relation between a square and a rectangle? So today's session is about square versus rectangle. So this is about finding the possible relation between a square and a rectangle. Let's see the discussion in brief. In order that I want to find the relation between a square and a rectangle, let me take a rectangle and a square separately. Imagine I take a square and I take a rectangle. Let's see the common properties identified between a rectangle and a square. Here in a rectangle, I see that each angle is 90 degrees, this being a square and this being a rectangle. Also in square, I identify that each angle is 90 degrees. So in both the cases, each angle of a square and a rectangle is 90 degrees. Coming to the second property, I see that in a square, all sides are equal, but in a rectangle, opposite sides are equal. So I can understand rectangle through a square because for a square, when all sides are equal, implies opposite sides are equal to each other. Therefore, all sides are equal implies opposite sides are equal to each other. Therefore, this retains the property of a rectangle. Therefore, a square with each angle being 90 and opposite sides being equal to each other can be called a rectangle. Therefore, every square is a rectangle, but every rectangle cannot be a square because all sides are not equal. We only have the opposite sides equal, but all sides are not equal, which is an essentiality for a square. Therefore, we can say that every square retains the properties of a rectangle, but every rectangle does not retain the properties of square. Therefore, every square is a rectangle, but every rectangle is not a square. Is how we understand the learning outcome. Therefore, my learning outcome is that every square is a rectangle, but every rectangle is not a square. Every square is a rectangle, but every rectangle is not a square, is the learning outcome, which makes me connect between understanding of a square and understanding of a rectangle as the special cases of a quadrilateral. Connecting square and rectangle. Is how I connect a square and a rectangle. Now next, let's see the relation between a rectangle and a parallelogram. Now that we have discussed about the relation between a square and a rectangle, where the learning outcome was that every rectangle is not a square, but every square is a rectangle. Similarly, let's investigate to search for some property connecting the trapezium, the parallelogram, and the rectangle. Parallelogram versus rectangle. So let's see the properties connected between the parallelogram and the rectangle. So here I consider a parallelogram, and in this column I consider a rectangle. Now we know that a parallelogram is in the shape of a sleeping or a slanting rectangle. Is how we understand the parallelogram. Now similarly, a rectangle is an erected property. Now let's see the properties in common. In rectangle, we have opposite sides are parallel. In parallelogram also the opposite sides are parallel. So these are the common properties identified between a rectangle and a parallelogram. Opposite sides parallel for a rectangle and opposite sides parallel even for a parallelogram. The next property is that in rectangle each angle is 90 degrees. So each angle is 90 degrees in a rectangle, but in parallelogram each angle is not 90 degrees. Therefore, I can see that opposite sides are parallel is the only condition for a parallelogram, and since in a rectangle opposite sides are parallel, irrespective of the condition that each angle is 90, every rectangle is a parallelogram. But every parallelogram is not a rectangle because it fails with each angle which must be 90 degrees. In parallelogram, each angle is not 90 degrees, but in rectangle, each angle is 90 degrees. So every rectangle is a parallelogram, but every parallelogram is not a rectangle. So let's make the learning outcome. Is how I make the learning outcome. Every rectangle is a parallelogram, but every parallelogram is not a rectangle because each angle is not 90. is how I understand the learning outcome connecting the parallelogram and a rectangle. Similarly, if I take a square, let me introduce a square. Every square is not a rectangle, but since opposite sides are parallel, irrespective of the condition that each angle is 90, again I can say every rectangle or even a square is a parallelogram. Every square is a parallelogram, but every parallelogram is not a square. This is how I connect between a square and a parallelogram. The properties are similar to rectangle and square when connected with parallelogram.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.